If you look under my desk right now, it is honestly a graveyard of cheap, tangled black cables.
Oh, I definitely know the feeling.
Right? You plug them in, they eventually break, and then you just replace them for like $10.
Yeah, that's the usual cycle.
But you shared a really interesting source with us today. It's an HDTV Supply product page for the, let me get this right, the DVIGear DVI-2840-AOC DisplayPort 1.4 Active Optical Cable.
That is a mouthful, yeah.
It really is. And our mission for this deep dive is to decode why on earth a single 40-meter display cable costs $545. So, okay, let's unpack this. What actually justifies that massive price tag?
Well, I mean, to call this just a cable really understates the engineering involved here.
Oh, really?
Yeah, we're looking at highly specialized data infrastructure. What's fascinating is the sheer volume of data it's designed to push. We're talking 32.4 gigabits per second.
Wait, 32.4 gigabits just for a display?
Exactly. That's what you need to support uncompressed 8K resolution video.
I know you're probably wondering why we don't just use, standard Wi-Fi or wireless casting for this. But uncompressed 8K at 32.4 gigs, wireless simply cannot handle that bandwidth reliably.
No, definitely not. Not over 40 meters, which is, over 130 feet?
Right, but standard copper degrades at that distance too. So how are they moving that payload without the signal just, completely falling apart?
So they bypass the limitations of copper entirely for the video feed by using glass.
Glass. Oh, wow.
Yeah, it's an active optical cable featuring this hybrid design. So 4 glass optical fibers carry that massive video payload, and the truly impressive part is how it's actually powered.
Wait, I was going to ask about that. How does glass draw power?
Right, well, it draws its ultra-low power directly from the source device, so there's no bulky external adapter needed.
But wait, how? The DisplayPort standard has that dedicated 3.3 volt pin, right?
Yeah.
So did DVIGear actually manage to miniaturize the electro-optical transceivers enough to fit inside the connector head?
Yep, they packed the transceivers right into the plug itself, just running off that tiny trickle of existing voltage.
That is wild.
It is. But you mentioned the hybrid design earlier, so alongside those 4 glass fibers, there are also 6 copper members inside the jacket.
Oh, okay. Since the HDCP handshakes require strict timing parameters, I imagine latency over 40 meters of pure copper would normally kill the signal. Are those dedicated copper lines just in there to handle that complex two-way communication?
That's the core of it, yeah. A display and a computer, they have to talk back and forth constantly for EAD.
Right, so the system knows exactly what monitor is plugged in.
Exactly. And also for HDCP, the copy protection, the copper handles the strict timing logistics, while the glass handles the heavy lifting of the video.
Okay, so it's like a high-speed bullet train for the video payload, but running alongside it is a traditional two-way radio system so the stations can actually coordinate the train's arrival.
Oh, that's a perfect way to visualize it.
So you've solved the data loss by using glass, but now you've created a totally new problem. I mean, glass is fragile.
You're very fragile, yeah.
How do you physically yank a delicate optical array through 40 meters of restrictive, dusty building conduit without just snapping it in half?
Well, if we connect this to the bigger picture, this gear is meant for really demanding professional environments. That means dealing with strict building codes. This cable is UL CMPOF rated.
Ah, CMPOF. That's a strict plenum rating. So that means if it's going into like a hospital ceiling or a broadcast studio's air return spaces, it won't off-gas toxic fumes if it happens to melt.
Spot on. It's crucial for those hidden spaces.
I'd assume it also needs a very low EMI or RFI profile, right? So it doesn't emit or pick up electromagnetic interference in the sensitive area.
Exactly. It's highly shielded.
Yeah.
But to your earlier point about physical installation...
The conduit issue.
Right, actually pulling it through a conduit. The engineers developed a very clever workaround.
What did they do?
The cable natively ends in tiny mini DisplayPort connectors. They have a very minimal XY profile, specifically so you can thread them through tight spaces without catching on anything.
Oh, that makes total sense. You bypass the physical limitation of the conduit without compromising those delicate transceivers inside the main plug.
Right, and then once you get the cable through the wall safely, you just snap those tiny connectors into detachable, full-size DisplayPort adapters.
And they stay secure.
Yeah, you lock them in with a specialized locking pin.
That is so smart. It's exactly like taking the legs off a couch just to fit it through a narrow doorway. And then, screwing them back on once you're safely in the living room.
I love that analogy. It perfectly bridges the gap between extreme data performance and the messy reality of real-world physical installation. It's just a complete hybrid infrastructure designed for absolute professional perfection.
So what does this all actually mean for you? It means the $545 price tag isn't just for a cord.
Definitely not.
It's for an engineering marvel that makes high-end tech function invisibly. So I'll leave you with this. The next time you are standing in a stadium or a high-end venue and you find yourself marveling at a massive, flawless 8K display, take a second.
Yeah, look a little deeper.
Exactly. Look past the screen itself and ask yourself, what hidden glass fiber highways are silently running through the walls to make that image possible?